Did you read this title and not believe me? Well, you should, because if the carbon and iron atoms in steel didn't react with each other the way they do, then your beloved high rises would just turn into a slice of bread. I mean, that's it. Bye. Oh, you're still here? You must want to know about the science. Well, to the lab. Since I made you hungry talking about this bread, let's take a closer look into what makes up the structural integrity of a slice of bread. What you see inside this bread is gluten, and gluten contains the strongest bond of all time, a covalent bond. And this is the type of bond that forms between two non-metal elements where each element shares one electron with each other. But like I said, only non-metal elements. And since we're all scientists here, let's all take out our periodic table out of our pockets. Wait, you didn't bring your periodic table? Well, don't worry, I got you covered. Here's where you can see the metal, non-metal, and elements that haven't yet decided who they are. So now that we've got the basics covered, let's go over the broad topic of what types of bonds that are available. Covalent bonding, metallic and ionic bonding. Let's break this down. In a covalent bond, you have two atoms that share one electron, and both atoms are fairly happy because they're both getting an equal amount of electrons. But in the ionic sense, we have one atom that completely steals an electron from another one and kind of drags the other one along for the ride. It's a big thief. And then in the metallic bonding, we have electrons that just flow freely towards positive directions, and all of the protons and neutrons are all spaced where they're very stable and they don't like to move very much. So if we look at this philosophically, we only have one option where both atoms are both benefiting from their bonding, and that's a covalent bond. So this is the main point about what makes it the strongest bond of all time. Now if we look back at our periodic table, we can actually see that carbon is a non-metal and forms
the strongest bond of all time.
But pure covalently bonded carbon is actually so strong, it's way too hard to deal with when it comes to building skyscrapers. And because it's so hard to deal with, we just give it to our women. So in order to get our carbon more malleable and able to use in building our skyscrapers, we have to mix in some other elements. And what we commonly refer to as steel is typically carbon and iron atoms melted together and blended, which forms a soup. But you may be thinking back to how I started this video with this gross, disgusting bread that's in my pocket. So what makes this bread, which has the strongest bonds of all time, different from a carbon and iron steel structure that holds up entire skyscrapers? So in order to understand how this happens, we need to zoom out a little bit, because we've only been talking about primary bonding, but we can start to look at the secondary structure, which is if we So secondary structures involve hydrogen bonds. So typically we have a negative site and a positive site. The negative site tends to be oxygen, nitrogen, sometimes even carbon, and the positive side's almost always hydrogen. And when these two come together, they form a secondary bond structure, and we call this hydrogen bonding. But if we look at steel, they form cubic structures, and these are endless structures formed of repetitions of what you can see here. But the bread is different because glucose doesn't form a unified structure like the steel does. It looks something like this, which is influenced by hydrogen bonding. So these tiny molecules become large skyscrapers because of the way they're organized, not solely because of their primary bonding structure, because like I said, I couldn't do this to a skyscraper. Now understanding the secondary structure is especially important in biology. It helps us understand the DNA and why it's a double helix, and it also helps us understand beta sheets, which is where the hydrogen bonds makes it fold over like a pancake. And actually, you know, I think you can learn more about it in this video. Yeah, you should really watch that one.